Hey, hi Shom. Hi Shammo.
Good evening, sir.
Good evening. Hi Anushka. Oh, hi Shitesh. Yeah. Shom is today very happy I am seeing because he wants to do a tougher chapter, right? Hey, hi Vishubhada.
Hi, sir.
Yeah. Just wait for some time. Let others also join in a couple of minutes. Bharat will be little late because he is stuck in traffic. Let Ayushman and Anush also join. Hey Vishubhada, if I want to add your WhatsApp number in the group, or should I add your mother's number or any other number that you have access to?
Mother's number, sir. Mother's number.
Mother's number, no? Okay, cool. I will add it.
हाँ, ठीक है.
I will
हाँ.
add it. Let me add it right away. Sharvik has also not joined, right? Yeah. So, hey, hi, Arush. Arush just dropped off, I think. So, he's just joining. Just give me 1 more minute, 2 minutes, 2 more minutes. We will start then. Hey, hi, Sharvik. Is there a problem with your internet show today?
Sir, this usually happens when I join, sir. Sir, usually disconnect and rejoin.
Okay.
Sir, don't know. I think for the virtual background, I think.
Could be. I don't know. Yeah. You're
Sir,
doing it.
as I am someone doing from both different devices, as it may be a problem.
Okay. Should not be. You're turning anyhow from laptop only, right?
Sir, yes, sir.
So should not be. Ideologically, it should not be a problem, right?
Sir, don't know, sir, why it happens.
Okay.
So Wi-Fi also high speed. Sir, I get disconnected.
Strange. Normally, it doesn't happen because the Zoom doesn't take much of bandwidth.
Yes, sir.
Yeah, doesn't take much of bandwidth. So today's topic is an interesting topic, right?
Yes, sir.
Yeah, so why so diluted yes with a low voice? A diluted yes with a low voice because I'm just waiting because this is a one of the most toughest topic in maths. Okay. But it's one of the most brilliant topic also that's associated with number theory. In competitive exams, you will get such kind of questions. There is no escape from it. And like I told, right, this is the deadliest topic. But it's the funniest also. Yeah, you are in mute if you're speaking, Shom. Yeah. Yeah, I will share my screen. So last class we did till here, right? Geometric progression we were doing, right? You all found it where easily you all did it, right? Right, let me right, you all remember this, right? When we did formulation like a into r1 r to the power s, sum of we did, right? Sum of in terms of GP was what? A into R to the power n minus 1 by R minus 1 we were doing, right? This is what we derived and we practiced few things. The reason because I will need this derivation or the formula in the coming things. Now, number of devices, right? You might be have, I don't know, you have studied in 6th, 7th, when you study, this is a very common thing. But that's how things get complicated. Hey, hi, Ayushman.
Good evening, sir.
Good evening. I heard that you bought book in the book fair, maths books, right?
Yeah,
Yeah, good. Your father sent me the photograph of the books. Good, good. Practice that book. Complete it. You will be really good after doing that book. Okay, that's a really good book. Okay. So
Sir,
we,
I bought many storybooks, sir.
no, maths book I wanted you to buy, not story books. Uh,
So this
Maybe-
Kolkata
so
one.
I also bought storybooks, but I also bought maths books too.
Yeah,
I'm like 4 maths books.
yeah. Good.
Sir,
Yeah.
sir, we want biology and physics book.
Biology, I'm absolutely North Pole and South Pole for me. Biology, social science, these subjects are.
I bought biology and chemistry. I
Okay.
did not get the physics part.
Okay.
Sir, actually, sir, biology my one of the favorite subjects, sir.
Okay. Okay. I hate it absolutely. Biology, social
Sir,
science,
biology is very bad, sir. It's actually very bad.
very bad. I also did never like.
Sir, we just have to
There
mug
are-
up those names, na?
Nay, there are so many diagrams and heart, erota, vorota, and paratha and
Yeah.
all those things.
So I hate anything that requires mug up. Absolutely.
Sir, like pleobrachia, then planaria, then
Beta, let's not
metridium,
talk about
hydra.
it. Okay. Let's start
Okay,
today's
sir.
class. Okay, chalo. Number of devices. Now you would have to think devices is very easy, studied in standard 6, right? If I take a number 24, 24 is what? 8 into 3. Sorry, 3. You wrote it like that, 2 cube into 3. How many devices are there of this number? Right. So 24, if I see how many devices will be there of 24, if I try to write, it will be 1, 2, 3, 4, 6, 8, 12, 24. 8 devices, right? Agreed? Very easy, right? Now let me take a number n. How are you getting those devices? That's the beauty of this. Let me take a number n. Any number n can be expressed. 2 is a prime number, 3 is a prime number. I can write p1 to the power alpha 1, generic format I am writing, p2 to the power alpha 2, till there can be pn to the power alpha n. Powers I am calling alpha, alpha 1, alpha 2, like this. Generally it is called alpha, okay? Where p1, p2 till pn are prime numbers, right? That's how you prime factorization you do, right? That's how it is done, prime numbers. Whereas alpha 1, alpha 2, alpha n are its exponents. How many, if number is so big, suppose I take 1,24,000, how many factors will be there? Or how many divisors will be there? How to derive it? Now let's identify how I got this. If I say similarly 24, how will I write? 2 cube into 3, 3 to the power 1, right? If I draw similarity, my P1 is 2, P2 is 3, alpha 1 is 3, alpha 2 is what you call 2, right? Alpha 2 is 2, sorry, alpha 2 is 1, right? Alpha 2 is 1. You'd be amazed to know the formula for the number of factors is nothing but alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 till alpha n plus 1. Just see it. 3 plus 1 is what? 3 plus 1 into 1 plus 1. Right? It is what? 4 into 2, 8 factors, right? You saw 8 here also, right? But how is it coming? Is this a magic? This is the power of a theoretical
Sir,
combination.
can you repeat, sir?
Okay. So if the power, if P1, P2 till Pn, they are prime numbers, right? And each of their powers are alpha 1, alpha 2, it is written like that. The number of divisors or number of factors will be alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1 till alpha n plus 1, right? This is how it is. It looks very strange, right? When I got for 2 to the 24, also 2 cube into 3. Memorizing or mugging up the formula is very easy. But the beauty is, how did it arrive at its first place? What's the logic behind it? It's a magic. No, it's not a magic. Let's see what happened here. 2 to the power 3 was there into 3 to the power 1. What is the combination? I will tell you combination by a very simple concept. Suppose you have to go to a party. You have 3 shirts, 4 trousers. Okay. Or you have 3 top wear. Top wear could be anything, t-shirt, shirt, anything, right? Top wear we call, and bottom wear is trousers, pajamas, anything we call bottom wear. How many bottom wear? How many combinations can you make for the party? It is 3 into 4, 12 combination. Try it out with your clothes also. The theory of combination says if two independent events are there, if one thing can be done in m ways and another thing can be done in m ways, together they can be done in m into n ways. Similarly, if 3 independent events are there, one done in m ways, another done in n ways, third thing done in p ways, together can be done in m into n into p. With top wear and bottom wear, if I add that you have 2 hats now, how many party combinations can you make? It will come as 2 into 3 into 4. That is 12 into 2, 24 combinations of party wear you can make. Right? This is the basic theory of combination. Let's see the trick here. Why did you got 8? See, the power of 2, that is 3. 2 can take, the power of 2 can vary between what? 0, 1, 2, 3. 4 values it can take. The power of 3 can vary between 0 and 1 only. Now let's see how. Let's manually write the combination. 2 to the power 0 into 3 to the power 0. 2 to the power 0 into 3 to the power 1. 2 to the power, 1 into 3 to the power 0. See it. 2 to the power 1 into 3 to the power 1. 2 square into 3 to the power 0. 2 square into 3 to the power 1. 2 cube into 3 to the power 0. 2 cube into 3 to the power 1. Check out if these numbers are matching with these numbers or not. This is 1. This is 3. This is 2. This is 6. This is 4. This is 4, 12. This is 8. This is 24. Got it? What is happening? What is happening here? Why this magic is happening? Because it's the power of combination. Because power of 2, if somebody wants to know in Hindi, 2 का जो power है, उसका values what it can take. It can take 0, 1, 2, 3. Any combination I am getting, because that's what factor is. What is factor? Because this is absolute. I have split into prime. Any combination of powers I take, it will give me one factor. Now 2 and 3 are independent, right? Independent events. Your top wear, bottom wear, hat wear. You cannot put your hat as a shirt, right? You cannot. You cannot put your hat as a trouser, cannot, right? They're independent events. That's why, right? The power of 2 and power of 3 are independent. My power of 2 can take, there are 4 possibilities. 0, 1, 2, 3, 4. That's why here 4 possibilities. Power of 3 has 2 possibilities. Total possibility is 4 into 2, 8. That's why we got it like that. Similarly, if a general number I write, P1 to the power alpha 1, the power of P1 can vary from what? 0, 1, 2, 3 till alpha 1. Similarly, the power of P2 can vary between what? 0, 1, 2, 3 till alpha 2. Here, what is the number of possibilities? Alpha 1 plus 1 possibilities. Here, what is the number of possibilities? Alpha 2 plus 1 possibilities. Similarly, Pn to the power n alpha n will have how many possibilities? Alpha n plus 1. That's why the formula for number of factors for any given number is alpha 1 plus 1, alpha 2 plus 1 till alpha n plus 1, because these are independent events. Did you get it? Let me know if there is any doubt or something. Feel free to ask if there is any doubt. Because combination is deadly chapter, I know that. Yeah, so
I will not understand the whole part.
who told? Just with the name.
Ayushman.
Ayushman, okay. Yeah.
Sir, same.
I know. The way you were staring, I knew it. Okay. At the screen, I knew it. Okay, cool. Did you understand the example first of all? Let me go by step by step. Did you understand the example of 24 that I showed you how the factors arrived?
Yes.
Yes. So what I am doing here, Every power of 2 that is possible, I am taking a power of 3. What are the power of 2's possible? See here, 0, 1, 2, 3, right? 0, 1, 2, 3. There are 4 possibilities of powers of 2, right? With each possibility of power of 2, I am taking what are the possible values of powers of 3 possible. 3, only 2 are possible, 0 and 1. So with this also, how many powers of 3 possible? 0 and 1, right? 0 and 1. With this also, how many possible? 0 and 1. With this also, how many possible? 0 and 1, right? So with each possibility of 2, I am getting 2. So 4 into 2, this 8 is getting multiplied, right? Did you get it? Here, this example. Same thing when I generalize. Suppose that number, I have a number called, suppose if I have a number, let me see if I have kept 2 slides for it. Yes, I've kept 2 slides, right? If I have a number that I can write 2 to the power 3 into 3 to the power 2 into 5 to the power 3, right? If I write it like this, my 2 can, all possibilities like 2 to the power 0 into 3 to the, with 2 to the power 0, so many possibilities will come, right? 2 to the power 0 into 3 to the power 1 into 5 to the power 0, 2 to the power 0 into 3 to the power 1 into 5 to the power, sorry, 3 to the power 2 into 5 to the power 0, right? Again, 2 to the power 0, 3 to the power 1, 5 to the, all possibilities will come, all combinations will start coming up. Now, power of 2 can take how many values? 0, 1, 2, 3, right? Power of 3 can take how many possibilities? 0, 1, 2. Power of 5 can take how many possibilities? 0, 1, 2, 3. So here 4 possibilities, here 3 possibilities, here 4 possibilities. The theory of combination says when anything can be done in m ways, n ways, p ways, we have to multiply to get the total combination. So my final combination will be 4 into 3, 12 into 4, 48 ways. That is how comes. So what I did you get this logic first here?
Yes.
Right. Same thing now I'm writing as a generic formula. If my number is some prime number to the power alpha 1, simply p1 to the power alpha 1 if I have, how many values that power can take? It will start from 0, 1, 2, 3 till what? Alpha 1. If I have then p2 multiplied with alpha 2, how many values the power of p2 can take? It can take 0, 1, 2, 3 till alpha 2, right? Similarly, if I have p3 to the power alpha 3, how many values it can take? 0, 1, 2, 3 till alpha 3, right? So this has alpha 1 plus 1 ways because 0 is also counted, right? Like here you have 3, so 4 ways we got because 0 is also counted. Here how many ways? Alpha 2 plus 1. Here how many ways? Alpha 3 plus 1. Similarly, just give me a minute, yeah. If my number has Pn to the power alpha n, at the end, my number of factors will be what? Alpha 1 plus 1, alpha 2 plus 1. It's a beautiful topic. I'm telling you, it is addictive topic. Alpha 3 plus 1 till alpha n plus 1. See the beauty of the divisors or factors that you studied in standard 6. Such a concept is there. That's how it is derived. So many factors. If anybody now gives you a bigger number, 1058742819, just break it up into prime factors power and you do use this formula, it will work. Yes, you have to remember the formula, but understand the logic, because if you don't understand the logic, what you will not be able to answer when I give you how many even factors are there, how many odd factors are there, because that time you have to understand the logic. That's why I'm asking you. You can ask me 3 times, 4 times, but did you get this logic of combination? You are saying truly, Ashom, hopefully, really, right? Honestly, you got it, right? Smiling means you would have got honestly. Yeah. Yeah.
Yes, sir, I got it.
Yeah. Ayushman, you also got it. Vashupratha, Sharbek.
Yes, sir.
Yeah. Others also got it. Anushka, others also got it. Kshitij, you all got it, right? So this is how the power of it works, right? Let's solve step by step. You will understand. Simply think that's why I told you example of your top wear and bottom pair. 3 shirt you have and 4 trouser they have. Just try in your wardrobe only how many combinations. With each shirt, 4 trouser can go, right? Each shirt, I give by T1, T2, T3, right? With each shirt, you can have 4 trousers, right? So total combination is what? 3 into 4, 12. Now I put one hat. With each combination, you can have hat, right? With this 12 combination, each combination I have two hat, H1 and H2. I can have either of these, right? So 12 into 2, 24 combinations, right? Some will look good and some combination will look good, bad. That's okay. So that's why trial and error you do before going to a party, right? Yeah. Here that solution you will not good, which combination will look good or which will look bad. So that you have to try and error. Okay. Then only will come to know. Okay. So now let's try to solve few simple problems. Okay. Where did it go? Yeah. Very simple. No. Shom and Shammo both are wrong. Which another Shom is there who has written? Which one you wrote the answer? Please write with the answer number. I mean, question number. This is very difficult to. No, question one is not 96. It's not 12 also. It's not 7 also. It's not 5 also. It's not 8 also. Now you got it. So it's right answer. That is right. Right answer, yes. Yes. Actually, there is a lag, I think, in the internet. Not 24. Let me get my water. Not 148. Yeah, Anushka. Right answer. Yeah, Shomna, it's the right answer. Second show. Not 148 is not.
Huh?
Hey, hi, Arush. Actually, you have missed something, so you will get stuck in this question because it is a new concept altogether.
Okay, sir. I'll wait till you can explain it.
Yeah, wait till you explain. Not 1000. Question 2 is not 1000. Yeah, first one is 10. I will explain one question, right? So that at least Arush also comes into understands. See, I explain later on. You can see my video and understand what's the logic behind it. Okay. 48. I have to find how many divisors or factors of 48 are there. Right. 48 I can write. I can always break any number into prime factor form. 2 cube into 3, right? Yeah.
Yes, sir.
Sorry. No. 2 cube into 3. 16 into 3. 2 to the power 4 into 3, right? 16 into 3.
Oh, yes, sir.
Yeah. Now I can break it like that. 2 to the power 4 into 3, 16 into 3. Any number P1, any number n, I can break it into P1 to the power alpha 1 into P2 to the power alpha 2 with these are powers, right?
Yes,
Alpha.
sir.
My total number of factors will be alpha 1 plus 1, alpha 2 plus 1 till alpha n plus 1 because the value of alpha 1 can go from 0, 1, 2, 3 till alpha n. So in this question, my 48 was 16 into 3, right? 3 to the power 1. So the power of 2 can take values between 0, 1, 2, 3, 4. we four, sorry. Yeah, and 4, right? 5 values were possible, right? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 5 values of power of 2 are possible. Similarly, power of 3, 0 and 1, 2 values are possible, right? So total number of factors will be what? 5 into 2, that is 10. Exactly this formula, right? How it got derived. This is the theory of combination. When two independent events happen, one independent event happens in m ways, second independent happens in n ways, third happen in p ways. Together they can happen in m into n into p ways. Got it, Rarush, now?
Yes, sir.
Okay, cool. Yeah, Ishwan finally got the answer, right? I explained this so that you all can understand with example, right? Second one is not 45. First factorize it, not 36. First check your prime factorization breakup. If your prime factorization breakup doesn't work, that will not work. If your prime factorization only if it is wrong, if I instead of 2 to the power 4, I by mistakenly wrote 3, obviously answer will come wrong. Yeah.
मेरे को समझ नहीं आया
Not 64. Shammo not 64. Kshitij not 60. Get the prime factorization right. First write in the chat how did you, what is the prime factor breakup that you got? When I like,
sir 1 minute I'll be right back 1 minute
yeah,
I'll come back sir just 1 minute
sure, sure. Oh my God. How did you get such big factorization? I never imagined. 2 to the power 17. But
Sir, not 17, it's 7.
7 is also wrong. 7 is also very high. Try dividing 2 to the power 7 will be what? 128 if I'm not wrong, right? 2 to the power 6 is 64. Divide by 128 if you can divide that number. Your LCM, the way you take, that is itself wrong. 2 to the power 4 is also wrong. That's why everyone is getting wrong. I told you, if your prime factorization at basic is wrong, you will start getting wrong. Now Shubham has started taking guesses. So yeah. So, 2 to the power 5, obviously, it will be 5. So rest powers also you have to be right. Then only you can do it.
Okay, sir. Sir, actually, sir, I found out five, sir.
5 is
I don't know
right.
how it became four.
Yeah. Two to the power 5. Then power of 3 you have written. Now power of 3 is wrong. 7 is right. 5 is right. Power of 3 is wrong. That's why I told you, if you can have to factorize
Sir, three cube.
guesses you have, if you try start taking, it will be right.
Sir, it's not guesses, sir.
Yeah, no guessing.
Sir, it's coming 2, 2, 2, 2, 2, 5, 3, 3, 3, 7.
Yeah, that's how it will be. Yeah. Two to the power 5 you got into 5. Yeah, absolutely, Ayushman. Your prime factorization is perfectly right. Now try to use this funda, what do you call this concept that I taught. You will get the answer. No. Yeah, Kshitij, right. Perfect. No, Shom.
Sir, I found the prime factorization, but I have not understood how to use the formula, sir.
So what I did is in this question, what I did, P1 to the power alpha 1 into P2 to the power alpha 2 into Pn to the power alpha n, right? Yes, prime factorization yours is also right. How many Shammo? Yeah, Shammo's prime factorization. How many values can power of 2 take? In this question I found, right? It can take 0, 1, 2, 3, 4. 5 values were there. How many values can power of 3 take? 0 and 1, right? 2 values it can take, like 2 to the power 0 into 3 to the power 0 can be one factor. 2 to the power 0 into 3 to the power 1 can be factor. 2 to the power 1 into 3 to the power 0 can be factor. 2 to the power 1 into 3 to the power 1 can be factor. 2 to the power 2 into 3 to the power 0, right? 2 to the power 2 into 3 to the power 1. You are seeing every combination is getting tied to each other, which means these are independent. So if the power is P1 to the power alpha 1, like here was 2 to the power 4, 5 possibilities were coming. In this case, 3 to the power 1 is there, 0 and 1, 2 possibilities. That's why I got 5 into 2, 10. Similarly, generic format, if I have alpha 1, alpha 2, my power of P can take 0, 1, 2, 3 till alpha 1. Power of P2 can take 0, 1, 2 till alpha 2. So here my possibilities are alpha 1 plus 1. Here my possibilities are, wait a minute, I will create some space here. Wait a minute, just a minute. Yeah. Alpha 2 plus 1. Similarly, if these numbers have n prime numbers till that, I can write slow dot dot dot. It can take 0, 1, 2 till alpha n possibility. Alpha n it can take. So alpha n plus 1. These are all independent events, right? The power of 2 has nothing to do with power of 3. Any power I take, I will get one factor. So how will I get the number of factors? Here alpha 1 plus 1 possibilities are there. Here alpha 2 plus 1. Here alpha n plus 1. I told you, right? If any independent events are there, if one can be done in M, one can be done in N, one can be done in P. Together they can be done in M into N into P ways, right? So similarly, the number of factors will be alpha 1 plus 1 into alpha 2 plus 1 till alpha n plus 1. Did you get it now, Arush? Arush, did you get it? I don't know. Yeah, Shoham, Ayushman, you are right. Shammo, you are right. Your answers of second one. Fourth is what? Fourth, you are right, Kshitij. Alpha is this denotion. Alpha is a Greek letter which we call anything to the power. When I am this way of writing is called alpha. That's like you have sometimes in angle you will see in trigonometry something angles in a triangle or sometimes it is theta, right? Alpha, beta, gamma, delta, theta. These are Greek letters. Just like X, Y, Z you have in India, Indian system, you have alpha, beta, gamma, delta, theta. So it's a common notation that people use. If you want to write it as P to the power A, very happy, you got no issues. P1 to the power A into P2 to the power B into P3 to the power till like this. Your answer will be A plus 1 into B plus 1 like
Sir,
that.
in direct and inverse variation, I've seen this alpha sign.
Yes, they use it. They use it alpha. That's why it is derived from Greek. So that's why they use it. Alpha. Directly proportional, you write it. Like if something X is directly proportional or something to write, you write X is directly proportional to Y. You write it like this. Direct and inverse proportions. Which one did you write? Fourth one, Shammo, right? No, still Not right. So third one also right, Kshitij. Very good. Yeah. No, 72 is not the answer of second one. Now you got it. Now yeah, got the answer. Yeah, yes, right, 96. Yeah.
So the number of divisors are 72 in the second one, sir.
No, not 72.
Okay, okay. So 96, sir.
Yes, cool. Right, Arush. That's why see, I can give the solution, but I want you all to fight it out. The more you fight it, you think it will get registered in your memory. You'll understand the mistakes that you are doing. Because if you go for any good competitive exams, this kind of questions you will get. Hmm. Third one. Just write the answer final. No? Fourth one is not 16. Third one, not right. 2 square into 3 into 7 is not. Question 4. No. 252 you have split only wrong. The prime factorization. Yeah, Ayushman, third one is right. No, 4 is not the answer of question 4.
Sir, third one is 3.8, sir.
Point. How can it be decimal?
Sir, can you hear me?
Yeah, I can hear you.
Sir, the third one is 3.8, sir.
No, how can it be decimal? It will be an integer answer.
Alright.
Yeah, right. See, now I will try to show you the solution. At least second one, at
Oh,
least one.
I wrote it wrong, sir.
Okay, okay.
It's
Then
80, sir.
yeah, right. Now you are saying right answer. Yeah. Now you're saying the right one. What's up, Bharat? Today Bharat will be seeing what the hell is going on. I missed something.
No,
Yeah.
sir. Stuck in the traffic.
Yeah, this is the toughest topic that I was telling now. So for competitive, we have started that. So at least chalo, when I explain, you will be able to understand something.
Okay.
Sir, I'm stuck between many answers. Sir, I'm stuck between many numbers.
1 lakh questions can be created of this topic. I'm telling you, this topic is a very vast one, but a beautiful topic. Chalo, at least I will show you one way, one question, at least that Bharat will also understand something. I have to find the number of factors or divisors of 30240. If you try to factorize this, you will get 2 to the power 5 into 3 to the power 3 into 5 to the power 1 into 7 to the power 1. This is what you will get it. This factorization is nothing. You break 3020, 3024 into 10. 10 is 2 into 5. Then you divide by 2 continuously, you will get it. Now, what my formula states, like if n is equal to any number, I write it as p1 to the power alpha 1. P1 is prime number. P2 to the power alpha 2. Alpha 2, alpha 1 are their powers. Till pn to the power alpha n, my number of factors nf will be equal to alpha 1 plus 1, alpha 2 plus 1 till alpha n plus 1. It's the multiplication. Why this logic happens? Simply because that's a combination theory, right? My power of P1 can take 0 to alpha 1, which means it can take 0, 1, 2, 3 till alpha 1. There are alpha 1 plus 1 values. Similarly, power of P2 can take 0, 1, 2, 3 till alpha 2, right? That's why it can have alpha 2 plus 1. So same question, here my power of 2 can take what? 0, 1, 2, 3, 4, 5, 6 values, right? It can take 6 values. Power of 3 can take what? 0, 1, 2, 3, 4 values. Power of 5 can take how many? 0 and 1, 2 values. Power of 7 can take how many? 0 and
values.
1, 2 values. 6 into 4, 24 into 4, 96. So there will be 96 factor. Try manually. If you have a day spend, you will get those 96 factors one day.
It's like
Yeah.
this, sir.
Did you get it, Bharat?
Yes, sir.
Yeah. Later on, see my video, you'll understand the logic
Yes, sir.
of hat and trousers. I have given some logic. Yeah, explaining how can you make party dresses.
Okay, sir.
Right? Just take
Yes.
2 minutes. You should be able to do it fast. Just try, give 2 minutes. Yeah. Did you understand, Vashuprada?
Yes, sir.
Sir,
Okay.
fourth one is 18, sir.
Yes, right. Right. You have to understand the form because till now you have been using direct formula. After this question, my formula will be useless. Then your logic will come into play.
Sir,
Yeah.
is the first one 7?
No. I want to go very slow in this topic because this is that kind of topic. Oh my goodness. Wait. Okay. See, the third one was very simple, right? What is 8? 8 is 2 to the power 3. 81 is what? 3 to the power 4. 125 is what? 5 cube. So how many factors will be there? 3 plus 1 into 4 plus 1 into 3 plus 1. Right? This many factors will be there. So just do it. How many will you get? It is 4 into 5 into 4. 4 into 5 into 4, which is 80. Right? This is what you will get. First one is 10, right, Bharat? You are right. Yeah. No, fourth one is not 8. Fourth one, see 252. How will you write 252 first of all? If you factorize 252, you will get 2 square into 3 square into 7 to the power 1. That's what you will get, right? 2 square into. If the power of 2 is 2, the 2 power can take 3 values, 0, 1, 2. Power of 3 can take 3 values, 0, 1, 2. Power of 7 can take 2 values, 0, 1. So here 3 is possible, 3 values, here 3 values, here 2 values. So final answer will be 3 into 3 into 2, 9 into 9 into 2, 18 factors. Right? Did you all get it?
Yes, sir.
Cool. Now the next slide, wait, let me have some water because that's a dangerous slide. Understanding that might require 2 to 3 times. Yeah. And now you found divisors. How many factors are there? If I ask you to, Rashom, please find me all the factors that you got. Second answer, what you got? 96. Find me the sum of all the 96 factors. What will you do? This number, I ask you to find sum of all the 96 factors. What will you do? It is a very interesting question. It becomes.
Sir, find all the factors and then add them.
Find them and add them.
Find all the factors, but manually writing all those are very difficult. Right? So that's a beauty thing.
Sir, calculators?
No, nothing. Calculator, you are not allowed. So how we will derive? Let's do the magic. See how can we derive it, right? Understand this. Okay, I don't know. If not required, I will create 2 slides. Okay, if it is not there. When I was writing 24, right? 24 is what? 8 into 3, 2 cube into 3, right? I will first explain you by example because it's not easy to understand, to be honest. How was I writing the factors? 2 to the power 0 into 3 to the power 0. Right? Wait a minute. 2 to the power 0 into 3 to the power 1. Just see it. Continuously watch it. What I am doing here. 2 to the power 1 into, if any mistake, also let me know. Because it is very small I am writing. Okay. 3 to the power 1. 2 square into 3 to the power 0. 2 square into 3 to the power 1. Right? See what is happening. The beauty you will see here. I am showing you with this example. These are all the factors. Agreed? Wait, 8 is there, right? 1, 2, 3, 4, 5, 6, 7, 8. Agreed? Everyone agrees with this. There is no disagreement in this, right?
Yes, sir.
Now let me add it. Okay, let me add it. Let me write it in a horizontal form. Beauty you will see. 2 to the power 0 into 3 to the power 0. 2 to the power 0 into 3 to the power 1. Plus 2 to the power 1 into 3 to the power 0 plus 2 to the power 1. Shit, yeah, I don't have much space. Remember, this is 1, okay? Into 3 to the power 0. Wait, I will write in a full line only. Otherwise, you will not able to understand. I will start from here. I need that space. 2 to the power 0 into 3 to the power 0 plus 2 to the power 0 into 3 to the power 1 plus 2 to the power 1 into 3 to the power 0. 2 to the power 1 into 3 to the power 1 plus 2 square into 3 to the power 0 plus 2 square into 3 to the power 1. Right? Right. 1, 2, 3, 4, 5, 6. Yes, last one is left. 2 cube into 3 to the power 0 plus 2 cube into 3 to the power 1. My dear, isn't it this sum? If I write it like this, see, isn't it the same? This and this are same or not? Let me know. First, understand what is there. If I take 2 to the power 0, see, is this same or not? All the terms are coming same or not? The distributive law of multiplication, right? You would have done previously so many times, right? A plus B plus C into D plus in standard 6 or somewhere you would have done, right? The same thing, it is coming same or not? Observe first. Yes, right. So is there a pattern? Yes, I am seeing the pattern. What is the pattern? Okay, my power of 3, here is 3. So 2 to the power 0, 1, 2, 3, it is increasing. Here it is still 1. So from 0, it is increasing till 1. Last class, that's why I taught you GP. What is a geometric progression? Geometric progression, if you see, these terms, 2 to the power 0 is 1. 2 to the power 1 is what? 2. 2 square is 4. 2 cube is 8. My dear, this is a geometric progression. Every term is increasing by multiplying, getting 2, right? If I take A, remember last class I did AR square, AR cube, the geometric progression. Remember, this is a GP, right? When there is a geometric progression, terms are written like this. Last class we did, right? AR square, AR cube, till AR to the power n. If there is a geometric series, what was the sum we derived last class? A into R to the power n minus 1 by R minus 1, right? Now, if I take this GP, right? How many terms are there? 4 terms are there, right? In a GP, if there are n, how many terms are there? 4 terms, right? 1, 2, 4, 8, right? 4 terms are there. This is simple, so you are able to calculate by manually. But 4 terms are there, right? It will be 2 to the power 4. A is what? First term is 1, right? 1, 2, 4, 8. First term is 1 into R. R is what? The common ratio, right? 2 to the power n. N is what? How many terms are there? First term, second term, third term, fourth term. 2 to the power 4 minus 1 by R minus 1, 2 minus 1. This was the formula, right? Do you remember now? Soham, Ayushman, Bharat, can you all get the logic?
Yes, sir.
Arush, others getting the logic?
Yes, sir.
Okay, I know for few this GP might be ruled. Just remember that if there is a series in which first this in AR square, first term is known as A, the ratio, the R is known as common ratio with which we are multiplying, right? Such sum of n term series Sn is given by this. So we derived, right? Now, think about it. If I have a number, right? If I have an n as a number, where my numbers are written as P1 to the power alpha 1 into P2 to the power 2 alpha 2 into P3 to the power alpha 3. I'm writing in a generic way, absolutely generic way, right? Pn to the power alpha n, right? The number of factors what we got, alpha 1 plus 1, alpha 2 plus 2, like this. Now, what will be the sum? You see the pattern here. My sum will be what? P1 to the power 0 plus P1 to the power 1 plus P1 to the power 2 till P1 to the power alpha 1 into P2 to the power 0 plus P2 to the power 1 plus P2 to the power 2 till P2 to the power alpha 2. This trend will continuously go on. Now, how to find the sum of 1? If I can do the sum of 1, it is nothing. Here I have to replace P1 with P2 and alpha 1 with alpha 2. Now, what is the sum of this? P1 to the power 0, P1 to the power 1, P1 square. This is nothing but 1 plus P1 square till P1 to the power alpha 1. My dear, this is also in GP, whose first term is 1. My common ratio, the ratio of second by first or the third by second, every consecutive terms ratio is P1, right? How many terms are there? Because, oh, acha, you wrote, can you repeat? I knew. Which part, Shom?
Sir, full part.
Yes, sir, me too.
You too, right? Now, this example part you understood, right? Example part.
Sir, like in the middle, sir, the brain will understand is some of that last it will break down.
Yeah, so breakdown, it has to be repaired. That's why. You understood
Yes,
the
sir.
example part, right? Example part 24.1. You understood till here, right?
No, sir.
No. You understood this step that I added this?
Sir, I understood the distributive part you did, na sir. 2 part by 0 plus 2 part by 1 plus 2 part by 3. That part.
This part you understood, right? I'm writing thing.
This part I understood.
So what I am doing, if you see the pattern, every pack where I'm doing this part, what I'm doing 2 to the power 0, 2 to the power 1, 2 squared, 2 cube. Every possible power of 2, I am multiplying with every possible power of 3. Agreed? So when in generic term, my power will be P1 to the power alpha 1, P2 to the power alpha 2. Every possible power of P1 will get multiplied with every possible power of others. If
Yes,
my
sir.
number would have been, wait, if my number would have been, suppose 2 cube into 3 square into 5 cube, how would it be? 2 to the power 0 plus 2 to the power 1 plus 2 square plus 2 cube multiplied by 3 to the power 0 plus 3 to the power 1 plus 3 square multiplied by 5 to the power 0, 5 to the power 1, 5 square plus 5 cube, right? Everything will start getting multiplied. Agreed? Because every
sir.
possible combinations will come. Same thing I just wrote in a normal P. Instead of 2 and 3 and 5, I wrote P1, P2 this. Instead of the powers, I took alpha 1, right? Now you got till here how this step got. Ayushman, Shohom, got it? Bharat, Sharbik, anyone, just let me know, stop me if any doubt there. Because this is a very critical step. The logic is very important here.
Sir, 2, we took all possible values of 2, then 3 and 5 and multiplied them.
Not all three, because I know if I having think about don't get confused. If I am having this kind of number, I know my factors will be like this. One factor will be 2 to the power 0 into 3 to the power 0 into 5.
Yes, sir.
One factor will be 2 to the power 0 into 3 to the power 0 into 5 to the power 1. Every possible combination of 2 will go with every possible combination of 3 and 5. What I did, this
Yes, sir.
statement that I wrote, this line that I wrote, this line was having all the possible combinations, right? That means 3 to the power 2 to the power 0 was getting multiplied with both this and this. Had 5 been there, another term would have come, right? It will get
Yes, sir.
multiplied. So if I have to find for one term. If I find from one term, it's fine. That's a P2, P3 are all same. Just numbers will change, right? How to find for that single term, right? What is this? P1 to the power 0, P1 to the power 1, P2 to the power this. P1 to the power, anything to the power 0 is 1. 1 plus P1 plus P1 plus P1 square plus P1 cube, right? Till P1 to the power alpha 1. How many terms are here? Right? 1, 2, 3, 4. Alpha 1 terms are here. What is my formula of a GP? Formula of a GP is sum is A into R to the power n minus 1 by R minus 1, where A is my first term, R is my common ratio. In this GP, my A is 1. My common ratio is P1. Just substitute. And how many terms are there? Alpha 1 plus 1. So what will be the sum? 1 into P1 to the power alpha 1 plus 1 minus 1 by P1 minus 1, right? Did you understand for this part till this part? First, let me know. Huh? Not only here. First step. Do you understand, like P1 to the power 0 plus P1 square, P1, it will be like this. What is the sum? This is a GPU, agree? Every term is getting multiplied with P1. You agree first term is 1. You also agree if every term is getting multiplied, my common ratio, that is the definition by which every term is getting multiplied. My common ratio will be P1. Like the example I used here, right? 2 to the power 0 plus 2 to the power 1 plus 2 square plus 2 cube. What is my this? 1 plus 2 square plus 2 cube. What is my first term? 1. What is my common ratio? Common ratio is 2. How many terms are there? N is equal to 4. Agreed? Same thing I am taking here general term. Power was 3. Obviously 1, 2, 3, 4. Here alpha 1 plus 1 terms are there. N is alpha 1 plus 1. Agreed? कॉमन रेशियो मींस क्या, हर टर्म मेरा P1 से मल्टीप्लाई होके आगे बढ़ रहा है, राइट? सो R मेरा P1 होगा, माय R विल बी P1, माय कॉमन रेशियो विल बी P1. गॉट इट? First term is 1. What is my formula of a GP? A into R to the power n minus 1 by R minus 1. R, in place of R, I have put P1. In place of n, I have put alpha 1 plus 1. In place of A, I put 1. Got it? Finally got it, right? Now I got for 1. Just a minute, my explaining you, my mouse battery also got over. Just give me a minute. Yeah. Wait a minute. Wait a minute. Yeah, now also formula is not finished. Okay, now I will require one more slide to do the formula. For previous slide, you all have remembered everything, right? So that number was what? Right, finally when I got P1 to the power alpha 1 into P2 to the power alpha 2 till Pn to the power alpha n, my sum was what? 1 plus P1 square till P1 to the power alpha 1. Similarly, 1 plus P2 square to the power till P2 to the power alpha 2 till 1 plus Pn square till Pn to the power n alpha n. This is what I got, right? Each term is becoming what? Last slide I derived it, right? It is nothing but P1 to the power alpha 1 plus 1 minus 1 by P1 minus 1. Similarly, what will be the sum of this? Into P2 to the power alpha 2 plus 1 minus 1 by P2 minus 1. Similarly, any terms are there, final term, Pn to the power alpha n plus 1 minus 1 by Pn minus 1. Did you get this formula?
No, sir.
Okay, no, right? Wait. By the way, let me go to before slide. First one. Good. That means you all are human beings. You all did not get this formula. Confirm it. Okay, I guys just got the confirmation. Okay, nobody can understand it first time. You all understood this one? This part? Anybody has any doubt in this part, this derivation?
No, sir.
No, right? If the same derivation, what I did, this derivations, you are, so that's a very clear, right? When I am adding 1 plus P1, I am adding 1 plus P1 plus P1 square till P1 to the power alpha 1. My GP sum is what? My GP sum is P1 to the power alpha 1 plus 1 minus 1 by P1 minus 1, right? Similarly, what is the second sum? Second sum is nothing but 1 plus P2 plus P2 square till P2 to the power 2 alpha 2. Only what changed here? Here also first term A is 1. Common ratio changed. Common ratio became P2. How many terms are there? N, what it became? N is nothing but alpha 2 plus 1. So what is my GP formula? A into yeah, A into R to the power n minus 1 by R minus 1. Exactly substitute in place of P2. A is 1. R is P2. P2 to the power n is alpha 2 plus 1. Alpha 2 plus 1 minus 1 by P2 minus 1. Same thing I have written here, right? Same thing, if more and more factors start increasing, you will start multiplying them, right? Did you get it now? Right, let me, he's smiling. Suppose I have 2 to the power, a number I have 2 to the power 3 into 5 square. What it will be? In this case, it will be what? My sum will be 2 to the power 0 plus 2 1 plus 2 square plus 2 cube into 5 0 plus 5, 5 to the power 1 plus 5 square. This GP, how will I write? My common, what is my P1? P1 is 2, right? 2 to the power alpha 1 plus 1. Alpha 1 was 3. 2 to the power 4 minus 1 by 2 minus 1 into 5 to the power alpha 1 plus alpha 2 plus 1. 3, 5 cube minus 1 by 5 minus 1. Got it? The application, I just used this formula. I showed you how to use it. Got it?
Yes, sir. Now I got.
Now got it? Very good.
So then why are we deriving this formula?
Because after one question, you will not be able to use the formula directly. You have to derive on your own. Every question formula is required to derivation. This formula you can use only for 2 questions. The moment I tell you find the sum of even divisors, this formula won't work. If I say you find the sum of odd divisors, it will not work. If I say you find the sum of divisors which are divisible by 9 but not divisible by 36, it will not work. So every time you have to derive it on your own. That's why I am showing you the derivation. Very good chapter, right? So enjoying it, right?
Uh, sir, no comments on this, sir.
Okay,
Sir,
let's.
opposite, sir.
Yeah.
Sir, opposite.
No, you will enjoy. This is a very great chapter. Slowly, you will enjoy this, right? Okay, slowly, you will like it. Okay, let's try these questions. This though was better, initial one only. How many factors are there? This is of initial part only. Okay, only I have given one, only I've given variations of one number. Just factor, break this 10,800 properly. How many factors you know the formula? Think how many perfect squares will be there, and then the sum. Only one value has been given. That's all. Dude, what is perfect square? You should know. 4 is a perfect square. 8 is a perfect, sorry, 9 is a perfect square, right? Any square number is called a perfect square, right? 16 is a perfect square. Just give me 1 minute. Yes, it is a perfect square. Any square is called perfect square. That's what it is called in English. I have also not done this question. Let me do it. First one, no. Bharat, wrong. Try at least first two. Right. At least that one you try. So all are easy only. Are at least how many factors do you will find? Factors do we will did so many last slide only. Let's go till there. Factorize 10,800. It takes 1 minute to factorize that. Very good. Who wrote 60 factors? Brilliant. Yeah, Shom, right. Some other Shom wrote it. 2 to the power 4, 5 square, 3 cube, right? Shammo, you have done right. Factorization, right? Now find the factors. And for the second perfect square, think of logic. That's why I told you, after a certain time, you cannot use my formulas. You have to think of thinking logic. Two, 4, 3 cube, 5 square. That till there it is right. Now find the number of factors. How many such possibilities are there? You have to think of the logic in terms of number of powers it can take. Ah, 60 show 'em right. No, there are more. Don't write it like this. There will be logical way of finding the second one. Think. Think. Like, like first one, everybody almost got it, right? First one is what? 10,800. It's very simple, right? 10,800 you will write as 108 into 100. 108 you will write what? 27 into 4. And then 100 you will write as 25 into 4. 27 you know 3 cube. 4 is 2 square. 5 is 5 square into 2 square. So this is what? 3 cube into 2 to the power 4 into 5 square, right? So how many factors will be there? The reason, because when I am finding, don't mug up the formula. When I am finding the number of factors, I know my value of 3. The power of 3 can take between 0, 1, 2, 3, 4 values possible. For suppose you have dementia and you have forgotten the formulas, how will you derive it, right? Okay. Suppose the 2 can have 5 values. Why? Because 0, 1, 2, 3, 4, 5. Right? 5 values. Right? Similarly, 5 has how many values? 0, 1, 2, 3 values. That's why I am doing 4 into 5 into 3, 60. Now, second one, you think of logic, what all values the powers can take. If you can get the logic right, then you will get the answer right. You have to think of logic. Hit and trial won't work. So, total factors are 60 factors. How can you have more than that factors? I am not asking you to find the number which is perfect square. How many such factors are there that are perfect squares? How many such factors? Think of the logic, what powers that they can take to make it a perfect square. Yeah, think of the powers. What powers? I am giving you a hint. Can the power be odd even? If I have a number, think logically. If I have a number 3 into 5, can it be a perfect square? Or 3 square into 5 square will be a perfect square. Which will be a perfect square? Think of logic. Logic. Because this chapter will
Sir,
be. Yeah.
I don't understand how 5 came. Sir.
How 5 came means?
So here 4 into 5 into 3.
Uh, where? Which step? Let me know the step.
Last step, sir.
How many values can 5 take? Power of 5 take 3 values?
Yes, sir.
How many values can power of 3 take? 4 values?
Yes, sir.
How many power can power of 2 take? 5 values? 0, 1, 2, 3, 4?
Yes, sir.
5 values. If any, these are all independent. In combination, if anything can be done in m ways, second thing can be done in n ways, third thing can be done in p ways. Totally, they can done in m into n into p ways. So 3 into 4 into 5. 3 into 4 into 5 is 60. Did you get now, Bharat?
Yeah, now I got it, sir.
Yeah. Think logically. 3 into 5 is not a perfect square, but 3 square into 5 square is a perfect square. Think. Why am I able to make, how can I make perfect squares? What is the values that they can take? Absolute logic will be required here. No. Think the way I'm writing these values here written 5 ka 0, 5 ka maine likha 0, 1, 2, 3, I wrote 0, 1, 2, 3. What are the values that it can carry? If I individually have to think what values it can carry, then you can easily multiply. What I am saying, how many factors? There will be 60 factors, right? There are 60 factors, out of which there will be X factors, X number of factors. X can be 5, 6, 8, 9, 10, 11, whatever it is. X number of factors which can be represented as K square, whole square. That is a perfect square. Understood now? What is the meaning of the question? Okay. There could be 25 and 225 is one of them. Don't try to, that's why I'm telling you, don't try to find by hit and trial. Your entire day will go away. Think logically as a combination. What, like I did 3, 4, 5. I did not write the formula now. I just took 0, 1, 2. What values they can take? Think. There are more than 10 such factors in this question, I know. It's a very interesting topic. Once you start doing it, you will not stop only. This is such an interesting topic. Think about logic, everyone. What values? Answer you have to is here. What values they can take? Each of the 5, 3, 2 between 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4. What is it? Is 3, 4? Till 3, 4. How, which values they can take? Yeah, they are ahead also home in this also. So every in sixth batch also I have done this. So they have now gone 3 classes ahead. They have moved to product of the devices, product of the factors they are in. They have skipped some, even, odd, everything done. Now product they are in my sixth batch also. Yeah, they are a little faster. Yeah. They practice 200, 300 questions a day also. That's another thing. By the way, from Feb 1st, when your revision will start, revision classes will start at a higher level, you will get subjective assignments also. It's all about practice. See, now I will show you. When I will show you the solution, you will find so very easy because you did not think. See, that's why I gave you the hint. 3 into 5 cannot be, 3 into 5 cannot be a perfect square. 3 square, my dear. What was this number? Wait, let me see. It is actually small, so it is becomes difficult to see there. Okay. 2 to the power 4 into 3 cube into 5 square. Don't you think only when my powers of each numbers are either 0 or even, then only I will have a perfect square? How can you have with a odd? That's why I gave you the example. 3 into 5, you cannot create a perfect square. 3 square into 5 square, you can write 3 into 5 square, right? Basic exponent, right? Exponent and powers. That means my power of 2 can take only 0 to 4, right? Power of 3 can take only 0 and 2. Power of 5 can take only 0 and 1, sorry, 0 and 2, right? Here only 3 values are possible. Here only 2 values are possible. Here only 2 values are possible. So how many perfect square can I generate when I multiply them? 3 into 2 into 2, 12 possibilities are there. 12. Did you get the logic? Let me know. Logic?
Sir, I don't understand, sir.
Okay. Bharat, okay. You did not understand, right? How can I form a perfect square? Think about it, right? If I suppose I have 2 to the power 4 into 5 square, with that if I have take one number as 3 to the power 1, can you form a perfect square with this? You cannot, right?
No, sir.
It has to be 3 to the power 0 then, right? Once I make it 3 to the power 0, you will write as what? 2 to the power 4 into 5 square. You will write as 2 square into 5 whole square, right? This becomes a perfect square. To make it a perfect square, my power of any P1, P2, anything has to be either 0 or 1. Even if this is 2 to the power 0 into 3 to the power 0 into 5 square, it is a perfect square, right? Because 1 into 5 square, perfect square. Even if it is 2 to the power 0 into 3 to the power 0 into 5 to the power 0, if it is a perfect square, it is 1, right? 1 square is 1. So, but if my power of 2 is 2 cube into 3 to the power 1 into 5 square, can it be a perfect square? Can it be? No, right? No. So what I am saying, to make it a perfect square, anything, any number, right? if it is of the form of 2 to the b to the power 2k2, wait, let me take some more space here, right? Any number can be a perfect square only if that number is of 2 to the power k1 into b is equal to 2 to the power k2. Basic your exponent funda, right? 2 to the power k3, like this way. Only then you can do a to the power k1 into b to the power k2 into c to the power k3. Sorry, 2 it will be power, I just forgot 2, right? Then only you can make it a perfect square. Without even, how can you make it a perfect square? Now, how can it be even? Either obviously 0 will also be counted because without, like I showed, 2 to the power 0, 3 to the power 0, 5 square making it. So 2 can take only 3 values because out of it can have a maximum of 4, right? Which are the even ones? 2 is even, 4 is even. Obviously 0 is also we have to take. In 3, how many values we can take? 0 and 2. Because 3 to the power 3, we cannot take odd values. In 5, how many we can take? 0 and 2. So I am left with only 2 values in 5, 2 values in 3, 3 values in 2. So how many total combination can be possible? If one thing can be done in m ways, second thing can be done in n ways, third thing can be done in p ways. It can be totally done in how many ways? M into N into P. So in this case, it is what? 3 into 2 into 2. It is how much? 4 into 3, 12 factors, combinations possible. Did you get it now?
Yes, sir. It should be 0 or even.
What?
Those numbers should be 0 or even.
0 or even has
Sir.
to be. See this combination, na? 2 to the power 0, 3 to the power 0, 5 square. 2 to the power 0, 3 square into 5 to the power 0. These are all perfect square, right? Coming, right? Suppose I take 2 to the power 2 into 3 square into 5 to the power 0, right? These are all perfect squares, right? 2 into 3 whole square. So whenever my powers are becoming 0 or even, it is becoming a perfect square. So how many 0 or even is possible for 2? 3. How many 0 or even is possible for 3? Because 3 has a maximum of power of 3. It is 2. How many are possible of 5? 0 and 2. It is 2, right? That's why we are multiplying, right? Did you get it now?
Yes, sir.
Shoham, others, Ayushman, Sharbik, Shrupada, do you all get it?
Yes, sir.
You all got it, right?
No, sir. I didn't got it.
Wait, let me explain you again. Wait, let me see if I have a slide left. Forget it, I will try to explain it. See, when a perfect square can be, suppose I have a number, n, right? Leave the third question that we will do in next class. First, understand this. I will take a very small number, 3 square into 2 cube. When I can make a perfect square, let me try. 3 to the very small number I am taking, 3 to the power 0 into 2 to the power 0, perfect square. 3 to the power 0 into 2 to the power 2, perfect square. Can you form 3 to the power 0 into 2 to the power 1 will be what? 1 into 2 is 2 is a perfect square? No. How can I form other perfect square? 3 to the power 2 into 2 to the power 0, right? Similarly, 3 to the power 2 into 2 to the power 2, right? Did you get
Yes,
it
sir.
here? Only,
Yes, sir.
only when my powers are 0 and 2, how many combination I got? 4. So how many values can 3, power of 3?
Sir,
Yeah.
sir, to the power can be only 0 or even numbers.
Yes, don't try to mug it up. See this logic. Why? Because until unless it become even number, until if it is 2 to the power 6, I can write it as 2 to the power 3 to the power 2. If that number is 2 to the power 6 into 5 square, I can write this number is 2 to the power 3 into 5 whole square. Then only I can make it, right? Until unless even how will you square it up? Right? So here, what are the powers of 3 that is possible? Only 0 and 2. Right? Here, what is the powers of 2 that are possible? Only 0 and 2. Here, 2 values were possible. 2 values are possible. That's why we did 2 into 2 and got 4. You can manually see these 4 combinations. They will only be perfect square. Did you get the logic now? Ayushman, Sharbek, Vashupratha, others?
Yes, sir.
Got it, right? So,
Yes.
yeah, so the sum again we will do next class. Yeah, because otherwise it will become too much that you all can digest. Okay. So,
Yeah.
Yeah, but if you want to know the answer, it is very simple, right? If you see the want to know how to write the answer of that, like what was written there, how do I broke it up? Yeah, I broke it up like this, right? This number is like this, right? If the same formula that I gave, I use, it will be the answer will be 3 to the power 4 minus 1 by 3 minus 1 into 2 to the power 5 minus 1 by 2 minus 1 into 5 to the power 3 minus 1 by 5 minus 1. All the GPs will come to. That is the formula that you will. It doesn't matter. We will do in next class. So again, I will do the derivation again and explain till you all understand. Yeah. So this is the beginning actually. Yeah. This is the beginning. Yeah. So we will carry on in the next class. Okay. So this will go till 3 more classes. After that, we will start with the revision of your comparing quantities mensuration of 7th but a better question. Okay, so we will continue in next class. So understand that, do practice, just take few arbit numbers 980, 450 and try to do such questions. You will be able to understand more. Okay, so that's how you have to do it. Okay, chalo. We will carry it on in the next class. I will derive the formula again because I know you will forget. So there is no brainer, but yeah, keep practicing. That's what I will tell you. Okay, chalo. Bye everyone. Bye.
Bye, sir.
Bye.
Bye, sir.